Do you remember that on a right triangle, okay, that, any triangle, in geometry or trigonometry, the vertices are named with capital letters, and the sides with little numbers opposite, right? And notice that this thing said C is the right angle, so that's C. So what's this? Little c. Now, does it matter which one is A and B? No, but what does it say A is? 64 degrees. So let's make it the one that looks bigger, right? So that would be little a, B, little c, okay? I mean little. Yeah, that's what I meant. Okay, little b. Okay, so now you can fill in, you know which things. You know C is 6, and you know the angle A is 64 degrees. Does that allow you to get enough information to find B?
Yes.
Okay, and what did you use?
Cosine.
Did everybody use cosine? Because angle A is the angle we're given. We want adjacent side, we're given hypotenuse. Adjacent hypotenuse is cosine. What did you guys end up getting for the answer? 2 point what? 6. What's the decimal places? 3, 0. All right. Okay. Now, let's do this right now. You guys, I'm going to answer questions on 5-4, but before that, 5-3 is due right now. Will you make sure your name's on it? Please don't forget names, you guys, because I've had a few assignments turned in without names lately. And I want you to write complete if you're complete, or if you're not complete, write how many you completed out of that. 5-3 part 2. Make sure you put 5-3 part 2 on that. Don't write the page number because it's the same page number as 5.3 part 1. Put 5-3 part 2, and we'll turn it in. We have an escalator that we want to know how long it is. We're going to call it X. X for escalator, right? All right. We have two pieces of information. We have an angle, and we have how tall the escalator is from horizontal. And so, well, first of all, let's change this to decimal degrees. How do I do that? What do I put in my calculator? Okay, tell me what that is.
10.36.
Huh? 10.36? Okay. 10.36 degrees. Okay, so I have this angle. From this angle, I have opposite side. And I want to know hypotenuse. So what would that be? London. You want to turn that in? Go put it in. Go put it in the middle, or the left side tray, third one down. Okay.
You take the degrees with seconds and then find the degrees of that angle, and then you can find the degrees of the other angle, so you can find that other side.
Well, we don't even need to know the degrees of this side, the angle, because if I have an angle and a side, I can find any other side on a right triangle, as long as I have the right. I know it's a right triangle, and I have one of the acute angles. Okay, so right here, I have this angle, opposite hypotenuse. Opposite and hypotenuse is what? Sine. So sine of 10.36 equals opposite 195.8 over x. And that's the equation I got to solve. Okay, thanks. Okay, so what do I do to get x by itself? Times by x, and then? Okay, so I get x equals what? Okay, good. Over sine of 10.36. Okay. You got the answer. Just put in your calculator. Okay. Any other questions on that one? What? 27? No, that's similar. I'm not going to do that one. You guys can do that one. I'll do 30. 30 is the tough one. Okay. 30. I'm going to do 30. This is the last one we're going to do. This one, I believe you guys, you have a building, right? Did this last period. And it has a flag at the top of the building, right? And it tells you that the flag is how tall? Is it 40? And I want to know, I have two measurements. I have a measurement of an angle to the top of the building and one to the top of the flag. And I'm given these two measurements. What's this one right here? The bigger angle is? What is it again? 54 degrees, 54 minutes. What's that in decimal degrees? 4.9 degrees. Okay, what's the other angle? 47 degrees, 30 minutes. What's that in decimal degrees? 47.5 degrees. Okay. All right, and what does it want to know? How tall is the building? So it wants to know from here down to there, right? Wants to know that. Now, we have a right triangle here. In fact, we got two of them, don't we? We got this one, and we got the big one right up here. Do I have any sides of those two right triangles? Is 40 feet a side of one of those right triangles?
No. Yeah, no.
Yay.
40 plus feet.
40 plus h is one of the sides, right? That's one of the sides of the big one. Okay, so there's a couple different ways we can do this, but this one's a tough little problem. So you got to know a little trick. I didn't really expect you guys to get this problem, but we are going to have one like this on a test in the future, not this next one coming up, but it's going to be coming up. We're going to actually do a group assignment where you're going to have to do one similar to this as well. In fact, I did this one with some of my classes we used to take and find the height of the H over the valley floor right here. I'm doing something similar to this. Okay, so we'd find the height to the bottom of the H, and we would take a measurement from out here somewhere, and then we'd go 100 yards down the road and take another angle measurement up. And it was a simple problem to this, but there's a little trick. Okay, this is the trick. I'm going to see if you guys do it. See this triangle up here? Well, man, that is the worst line I think I've ever drawn. Is that better?
You know there's a feature that makes it a straight line.
You know what? Coach Prince knows all those things, and I'm not sure. I'm so good at drawing straight lines that I don't need it. Okay, so you're gonna have to show me that sometime. Oh, you're talking about these things up here? Yeah, I use those sometimes.
He's just trying to work on a straight line.
Yeah, I'm trying to work on my straight line. So, all right. Okay. So anyway, this is the trick. I want you guys to see this. See this triangle up here? Is that a right triangle? No. Is there somewhere we can put a line somewhere in there and make two right triangles out of it? Come draw it. Does that make two right triangles? It's ruining my picture.
There's another feature that you can push back.
But anyway, I would have to say,
Every time I have Kai come up here, it's an adventure.
how do you get
There you go.
The recording's gonna have all this crap.
Do-
Dude, this is like Iron Man. Wait.
All right. Okay.
But I can find it. Not no. Is there undo? Is there a button set undo?
I don't think it undone. I don't think we can hit the undo 10 times and get what we had. There you go. Right there. Good job. Okay. So right here, you guys, it's going to give us two right triangles, right? Okay, so okay, so
Oh, is that where?
we have two right triangles. Now what we're going to have to do, you guys, in this triangle right here, I'm going to have to get an angle measurement other than the right angle. I'm going to have to get one of these two. And if you notice, since we have this angle and this full angle right here, we can get this angle down here, right? Work our way up and get one of these angles right here, which would allow us to find the length of this side. And after we find the length of this side, we'll be able to find the length of this side that's part of this right triangle, and we can solve and get our answer. Yes? Is there, say that again?
Like, should we use that with like the lines, like the angles? I don't know what it's called, but perpendicular line angles.
Well, yeah, in geometry you learned how to find different angles. This one, I think we're going to have to work our way up there. By the way, how much is this angle right here? 54.9 minus 47.5. Is it 7.4? Okay. If that angle is 7.4, what's this angle right here?
7.4 plus
90 minus 7.4, right? Which is 82.6. Is that right?
Well, then you have to switch it over to find one of the angles on the small triangle.
Okay.
By using
Well, before I do that, I'm going to probably need this angle right here, right?
yeah.
Well, we know that this one's 47.5, so can we get this angle? 90 minus 47.5, 42.5, and then what?
180 minus 82.6 and 42.
Yeah, because these three angles have to add up to 180, right? Because they make a straight line. So what is that one? That's 40 feet, by the way. Fine.
I got it. 1 second.
What is it?
42.5. 54.9.
Is it 54.9? Okay. I'm going to put this right here, 54.9 degrees. Okay, so, you guys, in this right triangle up here, I have a side. What side is this? What side is this in this right triangle right here? That's the hypotenuse. Now we want to know this side because it shares a side with this triangle right here. So what side is this if I use this angle right down here, 54.9 degrees? Adjacent. Well, we're trying to find from here to here, right? Ultimately.
Yeah, I did know that.
Yeah, we're trying to find the height. But we don't have any sides of this right triangle down here. So what we're trying to do is find this side because it's sides with this triangle right here. This length, and then we can find the height. Well, to find this length, we have to find this length right here first in this triangle. So we're trying to find this length in this triangle. And if you notice, I have this angle, hypotenuse, and adjacent. So which one's that? Okay, cosine of 54.9 degrees equals adjacent, which is, we're going to call it x, over hypotenuse, x over 40. Somebody calculate that for me. What is x? 40 times cosine of 54.9. What is that? 23 and 3 zeros. So we're just going to call it 23. Something like that, isn't it? Okay, 23.0002. But we'll just leave it as 23. Now that I have, oh shoot, that's this side right here. 23.023. Okay?
Now you have to use that to find the other one.
Now we have to use that to find this length. Okay? Well, we know this angle, 82.6. We know this side. This is the right angle down here, right? No, this isn't the right angle. This is the right angle. So we have this acute angle, 82.6. We have this side that's adjacent to it. We want to know hypotenuse, right?
That's not acute. So it's not a right angle?
This is the right angle up here. This is 82.6
Then
degrees.
you have to do the sine.
Close to a right angle?
It's close. It's almost 90. Yeah, we got to use cosine again, right? Cosine of 82.6 equals adjacent side, which is 23, over hypotenuse, which is y, right?
So 23 divided by cosine of 82.
Yeah, so if you saw this for y, it'd be 23 over the cosine of 82.6. Put that in your calculator. Tell me what that is. 1.577. Okay?
And then you have to put that one in.
Now we can find the height, the one that we want, right?
Wait, would be the times five.
No, if you multiplied both sides by y, these would cancel out. Now you have y times cosine of 82.6 equals 23. Then you divide both sides by cosine of 82.6. And that's where we got the 178.57. Jaleesa. Y is the hypotenuse of this one, right? We want to know this side. Should we use this angle or this angle? It doesn't matter. No, this side is the hypotenuse of this angle. This is the right angle. So opposite is the hypotenuse. So this is the hypotenuse for this triangle and this triangle. Okay, so now I have 42.5. I want to know adjacent, and I have hypotenuse. So that's cosine once again, right? Cosine of 42.5 equals adjacent, which is h, over 178.577. So times 178.577 times h, what do you get?
31.660.
That's what the book had.
So this is the kind of problem there's going to be on that test.
Hey, you guys, I am not going to put a problem like this on this test, but there will be one on next semester's test, like this. The test you're taking on Tuesday won't be on there. Oh, they are much more difficult than this. Actually, there's a couple that are this easy. There's actually the first three problems. The first three problems are easier than this, but the last two problems are harder than this.
But it's going to be where you have to find out.
Yeah, it's a lot of figuring like this. Yeah.
It's going to be the same thing except on a harder scale.
Yeah, and you're going to need to know the law of sines and cosines, which we haven't learned yet. We're going to learn those when we come back from Christmas break. Okay? All right. Okay, so today, you guys, the objective is to evaluate the inverse trig functions, find missing angle measurements, and solve right triangles. We've already been solving right triangles, except for now we're going to learn how to find an angle when it's missing. So if I can give, well, not if you're, if it's a right triangle and all you have is a right angle, do you know how to find the missing angle? No. So if I give you two sides of the right triangle today, that's what we're going to learn how to do, is how to find the inverse, the angle that's missing, okay? So like in this problem right here, you guys, given that the sine of theta equals 1/2, what is the measure of theta? And by the way, I'm recording this, so if you don't get all the notes down, you can go watch the recording, okay? So I'm going to move kind of fast. Yes, it's recording right now. Okay. Given that the sine of theta equals 1, you might want to go forward to about 18 minutes because first 18 minutes was doing those two problems we did. Okay. Given that the sine of theta equals 1/2, what is the measure of theta? So I want you guys to look at the unit circle. Sine of what angle is 1/2? When you know, raise your hand. Sine of what angle is 1/2? You guys all just memorize the unit circle. So now, oh, here, do I need to put them back up there? You guys got unit circles. I handed some to you. Hey, by the way, there's more than one right answer. Okay, there's that unit circle. Okay, so I'll put this unit circle up too. Okay, so, hey guys, what are the answers to this? Sine of what angle is 1/2?
30 and 1, whatever she said.
30 and 150. So, yeah, if you look at 30 degrees, you'll notice the sine, or the y value is 1/2, as well as over here at 150 degrees, the sine is 1/2. They both go up, positive, 1/2 unit, so you have two answers, right? So I could write both those answers down. Now, look at this one right here. When you know the answer to number 1, raise your hand. Okay. Colby, what is it? 16,300. Is that what you guys all got? Yeah, because notice that you went to the right 1/2. And you can either go up 60 or down to 30, but you went right, and the cosine is defined to be 1/2. So 60 or 300 now. So this one's 60 degrees. This one's 300 degrees. Now, really, there's an infinite number of answers. Why?
Because then it could be.
Say that again, Talon. You add 360 to it. What do we call those angles? Coterminal angles, right? So if I said name all, so if I said, Stetson, if I said name all the angles, okay, that the cosine of all of what angles will give me 1/2. If I wanted to name all of them that give me 1/2, I'd have to go 60 what? Plus 360k, right? Where k is an integer, can be positive or negative, right? Or 0. And that would give me all of them. So on your test and on your assignment today, sometimes it asks you, give me all the answers between 0 and 180. Sometimes it'll ask you, give me all the answers between 0 and 360, and sometimes it'll ask you, give me all the answers. It says all the answers, you give me all those, right? Okay? So, next one, tangent of theta equals 1. When you know, raise your hand. Tangent of what angle is 1? Okay, Drake, what is it? 45 and 225. Is that what you guys got? Okay, some people don't understand why it's 225. Why is it 225? Yeah, y over x. They're negative divided by negative is a positive, right? They're the same numbers. Okay. Got it? Okay. What about the next one? Cosine of theta equals square root of 3 over 2. Raise your hand when you got this one. Kimberly, what's 1? It's one of them. Okay. Ryan, what's 1? Tyson, what's another one? 330. 30 and 330, does everybody agree?
Yeah.
Okay. How about number 4? A little bit more difficult. What's cosecant defined to be? 1 over y. And so 1 over y. Anybody got it besides Ryan? Tyson? And Ryan? Anybody else? Okay, Rebecca, what do you think? She lied. Tyson, what do you think? One of them. 240 degrees? Well, if we go to 240 degrees, sine, or cosecant is defined to be 1 over the sine, so it would be 1 over negative root 3 over 2. So if I wrote negative 1 over root 3, that should be a negative root 3 over 2. But if I invert and multiply, I get negative 2 over root 3, right? Which I have to rationalize by times the top and bottom by root 3. Negative 2 root 3 over 3. That does give me the right answer, right? So, because when you have a number divided by a fraction, you flip the bottom fraction and multiply by 1. Negative 1, you get negative 1 times negative 2 over root 3. Or negative 1 over times 2 over root 3. Which will give you negative 2 root 3. 2 over root 3. What's the other one? Not 60. Yeah, 300. Because it's the y's are negative, and so you have to go down. So it's this one right here, 300. Okay? You get that idea? Okay, so pay attention in your assignment whether it asks you for the ones between 0 and 180, between 0 and 360, or all of them. Okay, now, this is really how we're going to use this right now. When you're looking for an angle, you are finding the inverse. Okay, so something like this. Sine of what angle is square root 3 over 2? Well, what is the answer to that? 60 and 330? So the answer to this is not 330.
No, yeah. It's,
Well, it's going to be 60 and 120. Okay, but notice the answer is an angle, right? You guys? So when we're doing these kind of problems, we're looking for an angle. Well, this is the way you write it in trigonometry. So that the x is by itself. You write sine with the little negative 1. What does that little negative 1 mean? Inverse. Remember last year when we talked about inverses? Okay, so sine inverse of root 3 over 2. Or we could write it as arc sine of root 3 over 2. Okay, these two mean the same thing. I don't know why mathematicians, some of them did this, but they didn't like that because the negative 1 looked like an exponent, so they came up with this little arc sine thing. Okay, so that's why they have it.
The x being inverse?
No, the x means it's an angle. It means what angle has a sine of square root 3 over 2? What angle has a sine of square root 3 over 2? Both of these all three of these things are saying the same thing. It's asking for the angle whose sine is root 3 over 2. So there's two ways to write them as inverses. These are the two ways right here to write the inverses. Okay, now, if you noticed, we haven't done any problems where we had to find angles yet. So we're going to be doing that here in just a second. But we got a couple other problems before we do that. Let's go to this one right here. So sine x equals negative 1/2. Here's the two ways to write that. Sine inverse of negative 1/2 equals x, or arc sine of negative 1/2 equals x. And you can see the answers are 210 and 330. This is more of the same. Don't worry about writing this one down again, you guys. Okay, I'm going to go to the next one.
Say the two ways on the calculator?
No. On your calculator, if you guys notice the button, look above sine, cosine, and tangent. What does it say? It just writes the sine inverse, the sine to the negative 1. So that means sine inverse. But sometimes your books and sometimes tests, sometimes they'll use sine inverse and sometimes they'll use arc sine. So you got to know both notations. But on your calculator, it says sine to the negative 1. Okay? All right, this problem right here, I want you to think about this. Tangent of the tangent inverse of 6/11. Why do you say that, Ellie? Yeah, they undo each other. It's kind of like saying 2 times 1/2. If I have 1/2 of x and I times it by 2, they cancel each other out and you get x. Well, same with this one. These cancel each other out and you get 6/11. Now that's only true if it's tangent and tangent inverse, sine and sine inverse, or cosine and cosine inverse. They have to be the same. Got it? Now, I'm not trying to trick you. I'm trying to make sure you understand the trick, because the next problem isn't going to be two things that are the same, like tangent and tangent inverse. The next problem is going to be a sine and a cosine. Okay? So what we're going to do right now is we need to find this. Now, you guys, could you type this into your calculator and get an answer?
Yes.
Yes, but I don't want you to do it that way, because you're going to get a decimal, an irrational number. We got to get exact, because on your standardized tests you have to. But I want you to understand how they relate to a triangle, so that's why we're doing it this way. So arc sine means the sine inverse. So let me do this. I'm going to draw an x and y axis. I'm going to put a point out here. Doesn't matter where, and draw a line to it. Okay, and I'm going to put the angle theta here. I'm going to put, so we have an angle in standard position. And I'm going to drop a vertical straight down. So that forms a right angle right there. Now, if you remember right, you guys, when we're looking for a sine inverse, or a cosine inverse, or a tangent inverse, we're looking for what? An angle. Remember I wrote that down on the thing? So arc sine of 2/3 is asking me for the angle theta. It's unknown, so I'm going to put theta in there. So my question really is, what is the cosine of theta? That's what I'm asking. When I ask for the cosine of the arc sine of 2/3, well, the arc sine of 2/3 is an angle. So I'm really asking for the cosine of that angle, right? Okay, so I'm going to set up this triangle here to get this. I know that the arc sine of 2/3 means the sine of what angle equals 2/3, right? So here's my angle theta, and I know sine is defined to be what over what? Yeah, opposite over hypotenuse or y over
Oh, so you do 2
y over r. Okay, y over r. So here's theta. So what's this length right here? The y. So it's going to be 2. Do we know this length?
Yeah.
No, that's the length we don't know. This one is 3, because opposite over hypotenuse or y over r is what sine's defined to be. We have the 2 and the 3 represent those two sides, right? Can I find x now? Because cosine's equal to adjacent over hypotenuse, x over 3, or x over r, right? So I need to find x. How do I find x? Okay, Pythagorean theorem, 2 squared plus x squared equals 3 squared. So I'm going to get x squared equals 9 squared minus, 9 minus 4 is 5. So x is equal to plus or minus 5. It didn't indicate what quadrant we're in, so
Square root of 5. Get rid of 5.
yeah. Oh, square root of 5. Yeah, sorry. So x equals the square root of 5.
Square root of 5.
What did I do? All right. Okay. So I have that side square root of 5. So what's the answer to my question? It's just the square root of 5 over 3 is the answer, right? Its cosine is adjacent over hypotenuse. Square root of 5 over 3. Huh? It doesn't. It's not asking for the angle measure. So that's for the cosine of theta. Arc sine of 2/3 represents an angle. We're asking for the cosine of that angle.
But you don't have
We're-
to solve it.
We're not. It doesn't ask us for the angle. It says the cosine of the angle. The cosine of the angle is square root of 5 over 3. Okay, but we're going to be using this in a second to find angles. And I'll show you those kind of problems. Mostly the reason they give you those kind of problems is to help you understand the concept of what's happening with arc sines and stuff with inverses. Okay, look at this one. I want you guys to do this one. Oh, I'm going to give you 2 minutes. See if you can get it in 2 minutes. Go. Okay, so we got 3/4. Well, we didn't use inverse. We had we were given an inverse. We changed it to cosine of theta equals 4/5, so we could draw the triangle with theta right here. And so this represents theta, so we're asking for the tangent of theta, which is 3/4. Okay. Let me show you where we're going to use. Let me show you how we're going to use the inverse now. Hey, Audrey, this is how we're going to use the triangle right here. Okay? Find angle B. You can use your calculator. See if we can do this. Think about what you know about right triangle trigonometry.
Now I don't even want to try. That's fine.
50 degrees? Okay, that sounds right. Well, you guys, I'm looking for angle B, right? I have the opposite side and the adjacent side. That's tangent, right? So it's asking me the tangent of what angle equals 17 over 14, right? And I just put it in my calculator as tangent inverse of 17/14, and it will give me the angle, which is 50 point what? Degrees, right? And that's what we're going to be using it for, to solve right triangles. So let me show you this. What does it mean to solve right triangles? It means to find the measure of all its sides and angles. All 6 sides, all 3 sides, all 3 angles. But if you know it's a right triangle, you already have one. So it means to find everything.
If you only only half your right angle.
If you have, oh, no, you're going to need, besides the right angle, you need at least 2 sides or a side and an angle, minimum, to solve it. Here's your assignment, right? No. Here's your assignment. Write it down. You guys liked that first assignment better, didn't you? Okay, hey, and I'm handing out your review. Okay? We're not missing anybody in this class, are we? No.